Right, we're back, so I'm just going to test, do sound check, set a timer, and we'll be on our way. Okay. Alright, time is set. Let's check what's going on here. Okay. And we will be doing the setup for Linux next week, so I'm looking forward to that. Okie dokie, I think we're ready to roll. So let's get this up. To share, there we go. Alright, so we have got I can't see the thing very well, hold on. We have got 8 lessons tonight and 1 chapter. So hopefully we will crank out these and get through them. That'd be super cool. And that'll be a good day. I'll bat these all. I'll do them all at the end if we get the thing, the award at the end and stuff. So we're already in the right directory. Show the. There we go. And we're on the asteroids part. So we're on chapter 3 of the asteroids. And yeah, we only got 7 lessons tonight. So let's crack on. And we'll get this done, and then we'll have a look at what's coming ahead next week. Right, so asteroids. It's arguable that a critical part of asteroids is the, well, asteroids. Let's create another class to represent an asteroid. Assignment: create a new class called asteroid in a new file called asteroid.py. The class should inherit from circle shape. Okay, so I'm going to make this full screen actually. It's a little bit hard to see. So we don't have an asteroid file, so nvim what is it, asteroid.py, and then create a new class called asteroid. It should inherit from the circle shape. So I'm going to cheat a little bit because I can't remember off the thing. So player, we did that last time, didn't we? So I'm going to take a little bit of this, not all of it. I'm just going to take this stuff because like just syntax and try and remember everything. Probably just as much as that really. I'm not going to take all that, but okay. So nvim asteroid paste. And then I'm just going to delete that. Whoops. Pass. The circle shape. Circle shape. Okay, so this is where we so the asteroid. Add a constructor with this signature. Okay. So thinking there. Just gonna delete this really. Paste. Self and radius. Override the draw method to draw the asteroid as a pie game draw circle. Use its position, radius, and a width of 2. Hold on. One thing I'm just going to update is radius. And for now, I guess. And then cat player whoops, circle shape. Order. Use its position, radius, and a width of 2. Let's have a look at the documentation of that. So, use its position, radius, and width of 2. Center radius. I need to update this really. So self.x equals x. Self.y equals y. Self.radius radius. Centered to pull as a float. X and Y. So hold on. Surface color center. Yep. So it's going to be like that. It's going to be self.x and self.y. Radius and width. Oh, must be. So self.radius. Okay, so I think I did that. Override the update method so it moves in a straight line at constant speed on each frame. It should add velocity, add self.velocity to its position. Get self.parent class circles. Okay, so update method. So it moves in a straight line at a constant speed. On each frame, adds on to its position. In the initial. Is there a position? Circle thing, circle shape. Draw. Look at the player one. Okay, right, makes sense now, I think. So it's going to be self dot position equals self velocity times v. I think that's it. In the initialization code in main, before the game loop starts, create a new pygame.sprite.group, which will contain all the asteroids. Okay, so in the main, so make a new group. Asteroids equals pygame.sprite.group. Like we did with the player class, set the static containers field on the asteroid class to the new asteroids group, as well as the update and drawable groups. Okay. Asteroids. How did we do it for Oh, yeah, forget. Sorry, it's outside the thing. So end, and it's going to be that line, like that. Okay. This ensures that every instance of the asteroid class is automatically added to these groups upon creation. We've written an asteroid field class for you. It contains logic for spawning new asteroids. Create a new file called asteroidfield.py and import it into your main py. Paste in this code. Okay. So import so from asteroid field import all. I guess import asteroid field. In main py, set the static containers field of asteroid field class to only updatable group. is not drawable, and it's not asteroid itself. Create a new asteroid field object in the initialization code. Okay, so open up thing again, so mbim main, and then we said asteroid field. So asteroid field dot containers equals, what was it? Updatable group, updatable. Whoops. Create a new asteroid field object in the initialization code. Asteroid field object. Like thing. Asteroid field equals okay, so let's run the game. I forgot how to run the game. It's a Python 3 main. Oh, hold on, we're gonna have to do this. What was this? There was a command again, wasn't there, about like making sure the game things were in. Whoa, no, I don't want to view solution. I want to look at the. Geez. Pygame. Hold on. Let me Google it. How to start Pygame. What was that? VM command thing. That's what I was thinking about. VM whole history. Ooh, kept a long history, blimey. Right, so we are Python. So this. Whoops. Right, okay, that's good. So, there's something wrong. Whoops, line 51 of asteroid PY. So, asteroid field. What's wrong with it? Try again. Hold on. Oh, how did that happen? O disappeared from there. Try one more time. Dang it. Another typo from Asteroid. Oh, and again. Oh, almost. Name asteroid is not defined. You meet asteroids. It's from main, is it? Yeah, and bin main. Hold on. What was that error? Asteroid not defined. Main.p line 20. Hold on. Hold on, I didn't add this, did I? So from asteroid import asteroid. Almost updatable. But no typo. I just typoing all over the place today. Blimey. It would help if I think you'd everything right, but you know what it's like sometimes. One typo, it throws everything off. Line 35, did I miss another spot? 35. Oh. That's where it is. Here we go. Right, so things aren't quite working. We've got this, but there's no asteroid. So Summit is up with the drawing method or update. It can be hard to tell which one. Okay, let's have a look at asteroid. So m asteroid. That's going to be white, definitely. Don't need any of that. I have a feeling it's going to be something with... That looks right. Draw a circle screen. That should be white. Self X, self Y, self radius 2. Self position equals self dot velocity times dt times the delta. We're in it again. Not sure what's going on here. I feel like everything's right. Oh, hold on. Is it because it's not big enough? Hold on. I'm going to make sure asteroids are spawning, moving across the screen. You didn't break your ship in the process. Well, they're not moving across the screen, that's one thing, so there is something up with that. So let's have a look at this part. Uses position, radius, and a width of 2. Oh, hold on. Hold on. Ah, they're not moving though. So something not quite right. I got a feeling, is it something to do with how we've written the update method? This was the same problem as last time, plus equals. Oops. Ah. There we go. There we go. Did it. Woo! Huzzah. Done with this step. Next one. Got me, that took a while. Hopefully these ones will be a little bit quicker. Collisions. You may have noticed that you can fly through asteroids without any consequences. We need collision detection. Now this is a fairly deep topic, but we're going to keep things simple. We'll treat everything, including our triangular ship, as a circle when it comes to collisions. Detecting a collision between two circles is simple. We calculate the distance between the center of the two circles. Let's call it distance. Let's call the radius of one circle R1, the radius of the circle R2. If the distance is less than or equal to R1 plus R2, the circles are colliding. If not, they aren't. So not colliding, colliding. So everything that collides inherits from circle shape. So that seems to be a good place to put collision logic. Add another method that to the class that checks for collisions. It should take one argument, another circle shape object, and return true or false. So circle shape. So okay, so engine circle shape. So def collision, and it takes one argument, another circle shape object. So self target, or yeah, say target. Each circle shape's position property is a pi gain vector 2. Use its distance 2 method to calculate the distance between the two shapes. Look at this. So position is vector 2. What was it? Distance 2. Distance 2. Okay, so it's going to be self.position. So if self.position dot distance to target I'll just say like is greater than 0, then return true, else return false. Now I'm not sure this is exactly right, so I'm going to log this. So like print, oh, I forget the things now, so like take that, whoops, don't have to proper yanking in thing yet. Position dot distance to target. Suppose I won't see it yet as well, actually. Hold on. So that after each update step in your game loop, iterate all the objects in your asteroids group. Check if any of them collide with the player. For collision detected, program will print game over. Immediately exit the program. Okay. So what was it? After updates, asteroids group. So asteroid, and it could be asteroid. Iterate over all the objects in your asteroids group. Check if any of them collide with the player. If the collision is detected. Okay, right, so asteroid dot collision, and it's going to be a player. Whoops. Hold on, so what did it say? print self.position.distance2.target. Sequence was expected. Okay, what's the problem here? A sequence was expected. Oh, slow going tonight, I tell you that. Hmm. So if a sequence is expected. I'm getting a sequence expected. Oh, I'll ask him a question. Go on, why not? He's there. Okay. cat. Oh, I'm such a dummy. Yeah. Okay. Perfect. Thank you, Boots. My goodness. You're such a kind fellow. Yeah, it has been, again, another long day. So, brain is not quite at full capacity. Oh, I gotta get better with Vim. I'm gonna have to do Vim tutor next week. Oops. Okay. And I think that's it. Boom, shakalaka. Done with this step. Woo! Boop. Let's take things further by giving the player the ability to shoot at asteroids. Oh, God, me, I'm going to get through this tonight. What are you doing with a gun in space? I don't know, you tell me. Cool. Bullets are small circles, move at a constant speed in a straight line, split up asteroids when they collide with them, are spawned by the player input spacebar and move in the direction the player is being faced. Create a new shot class to represent a bullet. It should also inherit the circle shapes that it can use our collision detection code. It should look very similar to asteroid class in that it will be drawn, have its position updated, use a new shot's radius constant and set it to 5. Okay, so a couple of things there. So whoops, and then constants. Got something new. That's going to be shot radius. Shot radius equals five. Any more radiuses? Play shoot speed to 500. Speed equals 500. Okay, shot class. Whoops. So cat asteroid. And then shot that UI. Why does it keep doing that? Probably just pasting the wrong way, but circle shape. Use a collision detection code. Should look very similar to asteroid belt. Class that will be drawn and have its position updated. New shot radius constant set to 5. So new grouping initialization code that contains all of your shots. So main all of your shots. Set a new grouping initialization code for all of your shots. Set that. If your player in your player class, add a new method called shoot. This method should create a new shot at the position of the player, set the shot's velocity, start with pi gain vector of 0, 1, rotate in the direction multiplayer facing, scale it up, multiply by shot shoot speed to make it move faster. Okay, so nvim player. I have to figure out what the hell is wrong with that. So define it's going to be self. Oops. So create a new shot in the position of the player. So shot equals shot. Player shoot speed. Okay, create a new shot at the position of the player. So self dot position. Set the shot's velocity. You put. Your player class had a new method called shoot. This method should create a new shot at the player position. Get the shot's velocity. Well, just while I'm thinking about it, I'm just going to add this. So if keys that self shoot. shit, this. Did I miss something? It said. Using a shot radius. Let's run this and see what it does. Warp. Oh, hold on. What the heck? Hold on, what the heck? Oh, that didn't work. So, shot. Okay. If you create a new shot at the player at the position of the player, set the shot's velocity Start with Picane vector 0, 1, rotate in the direction the player is facing, scale it up, multiply by base shot speed, make it less forever. Then your player class handle the spacebar, call a shoot method when it's pressed. Set the shot's velocity. Oh, hold on. Um, so velocity equals Pygame dot vector vector 2, 0, 1. Rotate in the direction the player is facing, so rotate itself dot rotation. Scale up by multiply player shoot speed to make it move faster. So shot dot position equals plus equals velocity times player shoot speed. Is that it? Try that. So print and then main. I think there was a bit missing here. Need to put shots on something. I think that's going to be going to be an drawable thing. Drawable thing. Drawable. Well, let's give him some salmon. Oh, I keep forgetting this. Like, so from shot import shot. So shot.containers update and drawable. I keep forgetting that part. I don't know why I didn't have to add it. I thought because maybe the player. Whoops. You know, for this part, just for time-wise, I'm going to need the solution files. Give me that stuff. See how different it is. So constant, so I added that. Play, shoot, speed, and shot radius. Main pi. Yeah, I did that. And then I made the mistake of like, yeah, I need to add this shot to the containers. Player, shoot. So, yeah, I thought it was going to be something like this. A bit different. Okay, so envim shot py. So self is position velocity times. Yep, I did that. So player. So it's a simplification really of this shoot method. Envim shot. Oops, wrong one. Envim player. Need to fix what's wrong with that. So it doesn't need the difference thing. I didn't think it did. So that's the main difference. So I did the same, but use self.position at y, x, y. I thought I could use that before actually. And shot.velocity equals pi gain vector. Right, okay. Whoops. What was it? Player shoot takes one positional argument, two were given. Okay, so it's going to be in the main, isn't it? Or player. Envim player. Yep. So we don't need that. Easy peasy. Game over. Cool. God, we're struggling with this one. Hopefully get this through this tonight. Half an hour. Get through these ones. Let's check one thing for a minute. Nope, everything's looking good. So rate limit, you probably noticed that the weapon on the ship is currently as overpowered as the original Zerg Rush. Let's fix that. Assignment, create a new variable on the player object to act as a time. It should start with a value of 0. Okay, so bin player, doesn't matter, timer. When the player shoots, set the timer equal to the new constant. I call mine play shoot cooldown and use it to 0.3. Then constants. What was it called? Play shoot thingy. 0.3. Prevent the player from shooting if the number is greater than 0. Increase the timer by DT every time the update is called on the player. Okay, so player. Edit anyway. Got to fix that. So say let's say if self.timer is less than it's less than or equal to 0, and do that. Decrease the timer by DT every time update is called on the player. Self timer minus equals DT. Rerunning game should now be able to shoot every 0.3 seconds. Whoops. Oh, I know why. This is called what was it? They shoot cooldown. That was nice and easy. On this step. Destruction, splitting, submit your repo. Okay, so bullets are flying, but they don't do anything. Let's kill some asteroids. There are 3 types of asteroids: large, medium, small. When a large asteroid is destroyed, it should split into 2 medium asteroids. When a medium asteroid is destroyed, it should split into 2 small asteroids. When a small asteroid is destroyed, it should disappear. For now, we'll just always make the asteroids disappear when they're destroyed. We'll handle splitting later. Add another collision check to the game loop. Loop over each asteroid, and for each asteroid, loop over each bullet. If a bullet and an asteroid collide, call the kill method on both objects to remove them from the game. Okay, so mbim main. So what was it? Check to the game loop. loop over each asteroid. We're already doing that. For each asteroid, loop over each bullet. Else. So if there's asteroid, no collision with that. Else. Hold on. If so asteroid collision bullet collision for each asteroid. Okay. Else for bullet for whole shot in shots. So it will be asteroid collision bullet shot. Hold on. Oops. If asteroid bullet collision shot, and then what we're gonna do asteroid dot kill, and then shot dot kill. Run the game, make sure you can destroy asteroids by shooting them. There we go, it works. Huzzah. Okay, I'm done with this step. Booga wooga. So in the original game, part of the challenge comes from the fact that that large asteroids split into smaller, faster asteroids when you shoot them. Let's support it. Instead of calling asteroid.killing a game, let's call asteroid.split. This is a new method we'll be writing on the asteroid class. To start, let's just have the split method call self-kill like before. This should keep the behavior same as before, but give us room to adding our splitting logic. I'll do split method to the asteroid. It should immediately kill itself. Think about it, the asteroid is always destroyed and maybe we'll spawn new ones. Okay, so in asteroid. New method. So fine. And what is it? Split. Self. Whoops. Self. And it's going to be self.kill. And then main. Update this. If the radius of the asteroid is less than or equal to asteroid min radius, just return this was a small asteroid. If the asteroid is less than or equal to asteroid min radius, just return. This is just a small asteroid that we've done, so okay. Less than or equal to. So if self dot radius is less than or equal to that, then return what's otherwise we need to spawn 2 new asteroids. So we want to import the random module. Random. Use the random uniform to generate random angle between 0 and 50 degrees. Use the random info. This will. Call this like angle equals. It's random dot uniform 20. So 20 and 50. This will be blue angle. I'm going to use the rotate method of the asteroid. Use the rotate method on the asteroid's velocity vectors. Create 2 new vectors that are rotate by random angle and minus random angle. Use a rotating asteroid. So self dot rotate. Compute the new radius of the small asteroids using the formula old radius minus asteroid min radius. So a new underscore radius plus self. Sorry, gone into deep thinking mode now. Hold on. Rotate. So first asteroid equals asteroid, and it's going to be the current asteroid position with the new radius. It's a new radius, yeah. So it's going to be self dot position dot x, and then self dot position dot y, and it's going to be new underscore radius. And then this one's going to be second. Set the first velocity to the first new vector. So to the new vector. Two new vectors. I think I missed something there. Hold on. Use the rotate method on the asteroid's velocity vector to create two new vectors. Use the rotate method. Hold on, what's that? Rotate method. it's going to be so first underscore first vector equals what's that? So self dot rotate random angle, and then second vector self dot rotate minus random. And then the velocity is velocity. So the first velocity is to the first new vector, but make it move faster by scaling up by multiplying 1.2. Okay, so it's going to be first vector times 0.2, and then second asteroid dot velocity equals second vector. Alright, see how he does. God, that was a bit of a long one. Blank. Ouch. So asteroid has no object rotate. Line 27 of asteroid cat asteroid dot. Use the rotating the asteroid's velocity vector. Oh. Hold on. I think I know the problem. So dot oops. Dot velocity dot velocity. Woo, worked. Oh, thank goodness. Thank goodness. Oh, did it. Bonza Canonza. Are we at the end? Okay, submit your repo. So, once you're satisfied with your game, push it up to GitHub. Okay. Username, repo name. Okay. So, git status. Git add all. Oops. Should have done this before as I was going along, but never mind. All lessons complete. Git push. Nothing, because there isn't one yet, so I'm going to add one. Asteroids. So GitHub. Let's get there. I just see my repos. Okie dokie. Okay, let's refresh. Boom shakalaka. So there's the repo, run all checks. Yay! Is it complete? Are we done so? Extending the project. You've done all the steps required, but if you want to make your project, you want to hear some ideas and do all this stuff. But we ain't doing that now. Not today. Not today, my friends. Come on, not today. Today, we're done. Does that mean we're finished? Correct. Boom. That means we done. Anything else? Is there a certificate or? Yes, here we go. Boom, course complete. I'll open that separately. Clean that. So really great course. Really great course. A little tricky for beginners, but challenging for beginners, and there was some what do you call it, in a good way, but some sections needed clearer instruction. Overall, brilliant. Right. Overall, brilliant. Because it was brilliant. 5 out of 5. Got that. I got a chest. Let's open the chest, see what's inside. Woo, got some things. Hey. Right, we got this, didn't we? So hold on. Let's download it. Let's shower next. I'll rewrite this a bit. There we go, got that one. Share on LinkedIn. So it's going to be Python. It's going to be game programming. Add media. And that's it, I guess. We done. Cool. Well, that's it. I don't think there ain't much to say apart from that, so here's what it is. I think next week's going to be interesting because we are going to take a little break from coding just next week. How many modules have we done? We've done six out of 23. So we're over a quarter of the way. And there's probably going to be more difficult ones along the way, but that's fine. We'll cook them up when we get it. We'll cook them. And it's going to be fun. The next one's going to be learn functional programming. Learn functional programming is going to be a little bit back to what we've been doing previously and stuff. But next week, I've got a new laptop. I've got a bit of a better setup now and stuff for that. So what we're going to do next week is we're going to spend at least one night setting it up with Linux. We're going to get it looking nice, and then the other night I think we might do just some Vim stuff, Vim tutor, just take it chill, and we'll go from there. But I'm going to finish up for tonight because it's been a long day. It's been a long one. And it's also been fun. So thanks for dropping by. If you watched, hope you had fun, learned something along the way. If you're coming back from the future, I still want to know where you got that time machine. Have a good one, and see you in the next one.